Alright, in this video we're going to evaluate tan inverse of negative square root of 3, or arc tangent of negative square root of 3. Alright, so when we're working with arctangent, inverse tangent, we should expect things to be a little bit more challenging than they are when we're working with sine or cosine, because we're more likely to be less familiar with tangent values than we are with sine or cosine values, because we learn tangent in terms of sine or cosine. We learned that tangent is sine over cosine, and then found tangent values using sine or cosine values. So we haven't really focused on learning tangent values directly. So when we see this input value for arctangent, for inverse tangent, it's not going to be as obvious to us what angle has that tangent value. But we can start with that sort of way of thinking. We can kind of copy the input value for inverse tangent and represent it as an output value for normal tangent. And then, since unless we know what kind of angle has a tangent value of square root of 3, we should use what we know about tangent, which is that tangent equals sine over cosine. So this expression in a tangent equals negative 3 square root of 3 can be translated as sine over cosine equals square root of 3. And now what we'll do is look at that number square root of 3 and think, is there any chance we're familiar with an angle that has this particular tangent value? And I would claim that the only prayer we have, the only chance we have that we'll have any idea what angle, what this angle needs to be to make sure that its tangent value is negative 3, negative square root of 3, the only chance we have is if this number square root of 3 comes from the only number we're familiar with that has square root of 3 in it, right? We've studied just a handful of numbers in this class, the sine and cosines of the, 30 degrees, 45 degrees, 60 degrees, and their multiples around the circle. And one of those numbers that popped up was square root of 3 over 2. And that's the only place we've seen a square root of 3. So if we have any chance at getting this value without a calculator, it's probably going to be because it's associated with something connected to square root of 3 over 2. And when we learned about square root of 3 over 2, we learned that it's a sine or cosine value that always goes along with 1 over 2, 1/2. And these two sine or cosine values always come along with the two angles pi over 6 and pi over 3. Right, so when we're working with either one of these angles, the sine value is one of these and the cosine value is the other. And so if we're going to have a chance at figuring out what this tangent value is going to be, we're going to want to find a way where we can take ratios of sine over cosine, divide this number and this number in a way where the result is square root of 3, or negative square root of 3 in this specific case. So if we're going to have any luck at that, we're going to need to take those two fractions and put them in a ratio. We're going to have to put like 1/2 on top and square root of 3 over 2 on the bottom as one option. If we play that one out for a second, we see we get 1 over square root of 3. We don't get square root of 3. So this isn't going to work. So let's go ahead and stack the numbers in the other order. Let's stack root 3 over 2 on top of 1 over 2. If we stack them like this, then the halves cancel and we get square root of 3. We get the number we're looking for. Of course, I've ignored the SIGN information. What color should we put that in? There is going to have to be some kind of sign discussion here. Well, we know we better get a negative one at the end, right? That's what our goal is. So somehow we're going to have to choose SIGN values that work for us. But we can see that if we can utilize square root of 3 on the top of this fraction, we can get I'm sorry, square root of 3 over 2 on the top of the fraction, then we can get the number square root of 3 out of this ratio. All right, so now we have to kind of piece these things together to figure out what the angle is. Well, remember that the fraction we've just created here is equal to this fraction, sine over cosine. So what we can do is focus on, for example, the top of this fraction and demand that it equals the top of that fraction. We see that a consequence of what this discussion is that we're going to need a sine value that is plus or minus square root of 3 over 2. So this helps us narrow in the angle that we're going to need. We're going to need an angle that has a sine value of plus or minus square root of 3 over 2. And we know that when angles are multiples of pi over 3, they have a sine value of plus or minus square root of 3 over 2. For example, I don't know, sine of 2 pi over 3 is actually root 3 over 2. And all the pi over 3 multiples give us that special fraction square root of 3 over 2. So now we know that when we're trying to answer this question, maybe we can go ahead and answer it on this right side. When we're going to finally draw our conclusion, we start with the given expression, tan inverse of negative square root of 3, and we know it must equal some type of pi over 3 angle. It might have to be 5 pi over 3 or 7 pi over 3 or whatever, negative pi over 3. It's gonna be some sort of pi over 3 kind of angle. To refine our answer, figure out exactly what sort of type of pi over 3 angle we need, we can consider a circle and consider the range of inverse tangent. It turns out that inverse tangent is very much like inverse sine. It can only output values in the right hemisphere. We need values between negative pi over 2 and pi over 2. So the specific kind of pi over 3 angle we need has to rotate into quad 4 in this negative way. It's going to have to be negative pi over 3. The probably most common error here would be to do pretty well with all this thinking, but get something like 5 pi over 3. 5 pi over 3 satisfies almost all of the conditions we need. It has the right sine value. The problem is it's too big. 5 pi over 3 is bigger than pi over 2. And so it's sort of an illegal inverse tangent value. It's outside the range of inverse tangent. So this becomes our result.